Welcome to Lesson 3. Last time we discussed the atom of data, the couplet, a value bound to its usage, written A arrow B. On its own, a single couplet is a lonely thing, one fact and no more. Data, as we usually experience it, is never just one fact, it's many gathered together. So in this lesson, we take our first step up the tower. We collect couplets into a set, and that set, humble as it sounds, is the first structure with genuine shape. It has a name you'll already half recognize from mathematics, a relation. So let's see what happens when couplets enjoy company. Let me recap the couplet in one breath. It is an ordered pair, A arrow B, one directed fact, a value on the left, its usage on the right. Now, a single fact rarely tells you anything useful. To describe even one person, you need several facts at once, their name, their birth year, what they did, and so on. So the natural next move is simply to gather couplets together. And here is the pleasant surprise. We don't need any new machinery to do it. We already have the perfect container from set theory, the set. Put couplets in a set, and you have built a relation. Here is a relation. 3 couplets describing the mathematician Ada Lovelace. Name points to Ada, born points to 1815, field points to computing. Bundle those 3 couplets into a single set, and that set is a relation. Notice 2 things that come for free from using a set. First, there's no meaningful order. The relation is the same whichever way we list the couplets. Second, there are no duplicates. A fact is either in the set or it isn't. That's all a relation is. A set of couplets, nothing more exotic. And yet, as you'll see, it's a shape you meet every single day. You already know relations intimately, you just call them by other names. Line up the couplets as fields and it's a record. Lay them across a spreadsheet and it's a row. Draw each couplet as an arrow from one node to another and it's a small graph. Ada in the middle, arrows fanning out to her name, her birth year, her field. Record, row, graph. 3 things that today live in 3 different kinds of software with 3 different query languages. But they are not 3 different things. They are one thing, a relation, wearing 3 sets of clothes. Because a relation is a set of couplets, it quietly gives us 2 more sets for free. Gather up all the left side elements, all the yins, and you have the domain of the relation. Here, the set of name, born, and field. Gather all the right side elements, all the yangs, and you have its range. Ada, 1815, and computing. Domain and range will matter enormously later, because operations like the join work by matching one relation's range against another's domain. For now, just hold the picture. Every relation carries a left set and a right set, and both fall straight out of the couplets it contains. And now the payoff for building on set theory. Because a relation simply is a set, every operation you already know on sets applies to relations, unchanged. You can take the union of 2 relations, their intersection, their difference. On top of those, the algebra adds a few of its own. Transpose reverses every couplet at once. Composition lets you follow one relation into another. Superstriction and substriction restrict one relation by another. You don't need to memorize them now. Each earns its own lesson later. The point is the leverage. Define an operation once on sets, and it works on every relation you'll ever build, and every result is, again, a relation. Let me put the relation where it belongs. Here's the tower again. The couplet sits at the foot, an element of G times G. Climb one step and you reach the relation, a set of couplets, which we write P of G times G, the power set, meaning all possible sets of couplets. That single step from couplet to relation is the whole pattern of the tower in miniature. Take what you have and form sets of it. Do it again and you'll get clans, again and you'll get hordes. But it all starts with this first gentle move, gathering couplets into a set. So, to summarize, a relation is a set of couplets, and because it's a set, order and duplicates simply don't arise. It's the shape you already know as a record, a row, or a small graph. It hands you a domain and a range for free, and it inherits every set operation, plus a handful of algebraic ones. That's a great deal of structure from one small idea. In the next lesson, we climb another rung and gather relations themselves into sets. And when we do, something very familiar appears, the table. In lesson 4, we meet the clan. That was the relation, couplets being social, and the first real shape within the tower. Thank you for your time. I'll see you in lesson 4 for the gathering of the clans.